Thank you for joining us today for our Builder Forum series, Part 9, and the upper steps. Today's workshop is presented by the Langley Green Buildings team and Dallas Hordichuk of Bernhardt Contracting. And as always, thankfully, we have Sarah Malaska and Jean Surendran supporting today. But unfortunately, we won't be hearing much from them today because we have an important engagement opportunity for everybody in the room, and we're looking for you to talk to us and provide feedback on our proposed Energy Step Code updates. So with that all being said, my name is Kevin Ram, the Green Buildings Manager here at the Township of Langley. Let's go ahead and get started. My slide changing. Go. Okay, so on the menu today, we'll do a real brief recap of where we left off with our last webinar on Part 3 and airtightness. Bit of a reminder. And then the second item is our Energy Step Code Part 3 and Part 9 adoption proposal and feedback opportunity. After our Step Code proposal, we'll get to the meat of the day, and that's our workshop on Part 9 and the upper steps, presented by Dallas Hordichuk of Bernhardt Consulting, and we'll close off there. Okay, so a recap of our last workshop. We talked about Part 3, buildings and airtightness, and this was in line with our long-term plans to support what eventually would be Energy Step Code adoption for Part 3 buildings. So in a nutshell, I think really what we need to understand is, and what we learned from Einar of E3 Eco Group was, if you're conducting the same level of practice you were before you started getting into step code or focusing on airtightness, if you're doing things the same way, you're probably going to be impacted once step code is adopted. On the left slide here, or the left box here, there's probably, I don't know, 15 or so buildings that provided airtightness reports at final, and roughly, I don't know, 40% of them were having issues with their airtightness. You really don't want to be scrambling near final with addressing airtightness issues. Einar also noted to take advantage of mid-construction airtightness testing. It's a better way to kind of find out where you're at in terms of your envelope performance. Again, rather than trying to scramble around and fix things, or even make changes to your mechanical systems to make up for your energy losses. And as a reminder, at the bottom right of the screen, tol.ca/gblearn, that's Green Buildings Learn, is where you can find all of our previous lectures, including the one on airtightness. Other notes, there's some challenges to the air barrier system. There's no single air barrier trade. Trades need good drawings on details to follow and good site instruction. Portions of the air barrier are installed by different trades. Tradespeople can unwittingly, unknowingly damage the air barrier. It's easy to miss problems during visual checks. However, there's still airtightness targets you want to meet. And this all kind of sums up into a repeated topic. It's the integrated design process. You want to apply it to air barrier systems, as Einar notes. It takes a high-performance design process to deliver an affordable, comfortable, healthy, sustainable, efficient, high-performance building. So the idea is get everybody in the room as early as possible and share knowledge to improve outcomes. Okay, so that was a quick summary of what some of the things we learned in the last workshop. I'd like to move on to our step code adoption updates. So a couple things here. We're using a new software for many. This is Microsoft Teams. Many of you may use it in your day-to-day work. However, for the Builder Forum series, this is relatively new. There's a few different options here of how you can communicate, and I'll talk about that shortly. So the agenda for this part of the presentation is I'll let you know where we're at in terms of Energy Step Code as a reminder, our motivations and rationale for where we want to go. And this is what we want your feedback on. We have 4 different methods of feedback of how you can communicate with us. I think most people are probably on a computer, some may be on a cell phone, a mobile device, some may be just on a phone. Not sure, but in either case, there is an opportunity for you to provide feedback in any scenario. So the first most instant way, relatively, is to use the chat box for questions or feedback. On the top of your screen, there's going to be a little chat bubble. You can click that. That's going to open a chat box on the right-hand side of your screen where you can type in and ask a question or leave a comment. I recommend leaving your email address as well. If there happens to be a flooding of questions and we're not able to get through it before 9:30, which is where we'll transition to Dallas, we're going to get back to you via email. At the end of the presentation, I'm going to have a Q&A slide or question and answer slide. So if you're having trouble with the chat or you just want to ask a question using your voice, please do. If we can do this, I'd prefer if you put your hand up. There's a smiley face at the top of your screen, probably near the chat bubble, where you can click that, and there's going to be a hand button. This allows you to raise your hand, and then Sarah or Jean can then call on you, and you can unmute yourself and ask your question. You can use email for questions or feedback in the familiar emails, greenbuildings@tol.ca. After this lecture, there will be 5 business days, and I acknowledge there's a holiday on Friday. So anyways, it's 5 business days. We'll take any questions or feedback. After 5 days, we'll close that consultation period. And as well, one last opportunity or method to provide feedback in the post-event survey, which we always send after the event. You'll have lots of questions about the day, and there will be one question, one opportunity to talk about the step code proposal. There'll be an other or an open-ended question where you can type in there as well. So there's 4 different methods for feedback. Please use these opportunities to share your thoughts. Okay, so that being said, for our consultation opportunities, we'll get started. So I'll be talking about our draft proposal for the BC Energy Step Code Updates. I'll talk about where we're at, what we're going to be doing. Step code at this point should be relatively familiar for all of you. If by chance this is the first time you're hearing about step code, go ahead, put that in the chat. We'd like to hear, we'd like to know that. Ultimately, an overarching step code reaching up to the 2032 federal target to be net zero energy ready. Improves these design and construction practices, improves health and comfort for occupants of buildings, demonstrates climate leadership, supports jobs and the economy, and ultimately results in less energy and lower bills. So where we're at today, we have step code requirements only for residential buildings, both for Part 3 and Part 9. Any permit with a residential occupancy meets the schedule in front of you, where it's 2022. We have harmonized our requirements where we were at Step 3 for both Part 3 and Part 9 buildings in the DP or non-DPA areas. And beyond that is the topic of the day, and we'll get to that shortly. So some stats on our residential application of step code. We track a lot of data. We really want to know how step code is being successful in the community. What we found was, out of all of our building permits that have reached final, so we've had roughly 497 or almost 500 building permits that's reached final. 160 of those permits, or otherwise 32% of those building permits, exceeded step code requirements or met a higher step. So it's not just a little bit of buffer, this is into the next step of whatever they were required to do. So that lets us know that industry that's great if people who are trying or experimenting with new ideas are benefiting. Most of the comments that we track for Part 3 buildings were usually around documentation, and design methodology. So documentation, just to be clear, is really if we ask you for a certain number of documents, which is all on our website, and you're missing one, it's flagged. We cannot process it if you're missing your compliance form or your energy modeling report or what have you. If it's missing, we simply stop the process and let you know. So that's where we find document issues. However, it's relatively light. We'll let you know. But however, that does slow down the process if your documentation is incorrect. And the rest of it's around design methodology clarifications, and that's fine. And we're here to answer questions. Please do. And other minor issues. The regional state here around Part 3 non-residential energy step code adoption, which is what we're focusing on today, as well as Part 9 buildings. There's 3 tiers here. So there's Step 3, Step 2, and Step 1. You'll see, I don't know, roughly a third or a quarter of buildings are already at Step 3 for non-residential Part 3 buildings step code. A decent chunk are at Step 2. Township of Langley here is blank because we have not adopted yet, and we'll be proposing what we're adopting today. The regional current state for Part 9 buildings between the years 2022 and 2026. I'm not mapping anything else further than that. And as well, this chart may be slightly out of date if somebody or any municipalities have made recent updates. And I do note there will probably be updates to other municipalities shortly. There's 5 tiers here. We have a small handful of municipalities that are soon to be or already at Step 5. There's a couple at Step 4 or a few at Step 4. The large majority are at Step 3, and some are still at Step 1. This is not every municipality in the province, but it's to give you a sense of what's going on regionally. So our overarching, our energy step code adoption plans ultimately are aligned with our climate action strategy goals. The climate action strategy was approved in 2021. Buildings are a large chunk of the CO2 or the carbon or GHG emissions portfolio. And we anticipate our building policies aligning with the climate action strategy. One of the big moves are to eventually have zero emission new buildings, supporting step code incremental increases in requirements gets us to that goal. We conducted a very rigorous and detailed study on implementation of Part 3 Energy Step Code for the Township of Langley. We did publish this report. You're welcome to see it on our website. It really focused on staffing resources and let us know that for successful implementation, you want to have the capacity in-house, and which we do, which is part of the Green Buildings team's role. We did a technical analysis as well of how does Part 3 Energy Step Code adoption meet our goals. And long story short, Step Code does provide significant GHG reductions, energy reductions, supports the climate action strategy. And as well, our simulations show about 69% reduction in GHGs by 2050. However, that is not the end goal. So we will anticipate other policies to help us reduce our GHGs to meet those end goals. Our consultation on Part 3 noted nothing's really unexpected. Step 2 is not an unexpected starting point. There's needed to be an acknowledgement of how energy intersects with the aesthetics of a building. That's acknowledged. Lead time was important. A notice of when Step 3 would be required was important. A call for continued education for the development community, and that's why we're here. And acknowledgement that these industries can benefit from direct resources from green buildings through answering questions and support. Okay, so to Part 9 for residential non-apartment BCBC updates. So the BCBC in the province has been working on the updated 2022 BCBC. A part of the updates of the 2022 BCBC is a proposed Step 3 baseline minimum. Okay, so that's really important to acknowledge here. Step 1 and 2 are removed or being proposed to be removed from the upcoming code update. The township, since the adoption of step code, has been a leader in its implementation. We were one of the first adopters. We have GHG DPAs where we elevated step code requirements. And in fact, the Builder Forum series, this started some few years ago with Robert Baker to support step code consultation. So all of this really was about being a leader in energy efficiency and a leader in energy policy. So thereby, if step 3 will be the baseline minimum in the new code update, the township anticipates our requirements are above the baseline and we maintain our status of being a leader in the energy realm. So to clarify, using BCBC terms, the building types that we are targeting for the current proposal, a whole bunch of BCBC stuff here, but basically for part 3 buildings, we're focusing on offices, and the tables are in front of you, and retail, referred to as other business, personal service, or mercantile occupancies, and as well as type in A and B per 10233A-E table, which includes schools, colleges, libraries, rec centers, hospitals, and care centers. And as well, part 9, 93663A, at current time subject to change, this set of buildings as well. Okay, so this is what we've been waiting for. This is the step code adoption proposal. So the first cell here, if you are a part 3 builder, this is where you really want to focus on. Come 2023, we're anticipating a starting point of step 2. Now, we've done a lot of work in analyzing the impacts to the township and how to meet step code for these type of buildings. So there is there's a few notes here on the left cell. Buildings that are bigger than 20 or equal to or bigger than 2,500 square meters or 2 stories and greater will need to meet step 2. Now, what this also means, buildings that are smaller than 2,500 square meters and only 1 story together will not have a step code adoption at this point. Come 2026, we'll anticipate a requirement of step 3. That leaves 3 years in between adoption. The next line are for part 9 builders who build single family dwellings, duplex, triplex, townhouse, or row house. This excludes part 9 apartments. In 2023, anticipated step code elevation to step 4. And lastly, part 3 A, B occupancies, 10233 A to F, which are those schools, colleges, healthcare centers, rec centers. We're anticipating a step 1 requirement. Okay, I can't see if anything in the chat, and it looks like nothing's burning at this point. There is going to be a Q&A time if you want to ask questions verbally.
Nothing,
I will highlight.
Nothing yet. You're good to go.
Oh, great. Okay, I will highlight. There's that's great. Okay. So there's 2 other pieces important that are important here. Are the implementation date. It's January 2nd, or basically the first time you can provide an application in 2023. Suppose we're closed on January 1st. However, for those who are asking, what if I'm in stream? If you are in stream, that's defined as rezoning, development permit, subdivision, or heritage, there is a staggered implementation. Okay, and that's proposed as approximately 1 year from consultation, which is today. So that would roughly put us into June, July. Okay. And to confirm, it's new building permit applications that trigger the step code requirement per January 2nd. Or if you're in stream, there's a bit of a stagger. So I'm gonna let this sit here for a second. We're basically at the end. There's a Q&A, but please take a look at this and formulate your questions if you have any, or feedback or comments. I think I can move on.
All right, Kevin,
And
I have a question on
sure.
that slide at the bottom. Is it supposed to say 2022 or 2023?
Oh, thanks. Thank you, Sarah. Yeah, that is absolutely right. That's a typo. That's 2023. Thanks for highlighting that, Sarah.
Great. Yeah, we just had someone in the chat ask that as well. So
Great. Well, great. Yeah, wow, eagle eyes. That's great. Thank you for that. Okay, as prior and today and ongoing, we will continue to provide support to industry, continued and expanded. We have plans to continue growing our support to everybody on the call today. We'll continue the Builder Forum series, support meeting and exceeding step code and other performance-based design. I'll highlight and thank you. I don't know how many, Sarah, how many people in the room today?
we have 138.
Wow, that's fabulous. That's awesome. Builder Forum series is the benchmark here for municipal training across the province. In fact, right after this lecture today, I'm talking to BC Hydro about the success of the Builder Forum series because they want to know more about why are you here in the room in this community that's being developed. We'll continue to provide support from the Green Buildings team, so give us a shout. We have a penchant for compliance. We want to support compliance. We want to make it apply consistent level of review and rigor across the board. Give us a shout if you have a question. Just call or email. We really want to ensure that people can get through this as smooth as possible. As noted, documentation seems to be or was an issue. Check our website. There's a list of things printed out and hand it to your team, hand it to your modelers, hand it to your design folk, and make sure they tick off the boxes. We're here to help detect problems before they're problems, and we're always focusing on continuous improvement. Share your learnings with us, please. Okay, so that's it in a nutshell. That's our proposal. This is your chance for feedback, and we do want your feedback and questions. So we'll give it a minute or so. I can't see anything here, so I'm just relying on Sarah. And Sarah, you're not saying that there's a flooding of comments or questions coming in, so I'm guessing this will be a short period.
There's no questions yet.
Okay.
Anyone at this point, because we're in the Q&A, if you want to unmute yourself and ask a question, then feel free to go ahead.
Great. Yeah. Thanks, Sarah. Yeah.
I have a question. Anton
Go
here
ahead.
Anton here from Central Windows. What is the current, just correct my ignorance here a little bit because I try to keep track of every municipality. What is the Township of Langley's current step code? Is it step 2? For part 9? Sorry, for part 9.
So for our current 2022, for right now, we have step code for only residential applications for both part 3 and part 9, and it is step 3.
Step 3. Okay, perfect. So we're going from step 3 to step 4.
We're going from step 3 to step 4 for part 9 buildings only, for single family duplex, triplex, townhouse, row house.
Okay.
Basically, we're excluding part 9 apartments.
Yeah, and I just asked the question because in my personal experience, step 3 is the best learning step. It's where everybody starts to really understand how to do things well. So my fear is when I see municipalities jump from step 1, step 2, all the way to step 4 and not go to step 3. Step 3 is a really good time to stay on for a long time if you want to get a lot of buy-in, a lot of change in what we do. So because there's a lot of time when products and things need to ramp up, and with supply chain issues going on, it's very helpful to take time as we progress through to ease into it. So it's kind of what I call the learning stage. So it's good to hear that we're on 3 and going into 4. So thanks.
Thanks for your comments, and thanks for your question.
Hi, Kevin. This is Navdeep from ePro Consultants. I had a question about the step code compliance for residential.
Okay.
Is it GHG requirement?
Sorry. Can you ask your question again?
Is there a GHG application requirement as well
For step
for
step code?
for residential single family homes at the moment?
Are you talking about a GHG DPA report?
Yes.
So that depends on where you're building. So if you're building in a GHG DPA area, yes, there are requirements that are different than, that's just a different thing altogether. But if you do have any questions about GHG DPA, just email us.
Okay, perfect.
We'll take that for a separate conversation.
Okay, so that's normally submitted along with the step code reports.
Step code is a BCBC requirement that we have adopted, so that's a BCBC thing. So yes, that's a building permit requirement. GHG DPA reports are submitted at DP stage.
Okay, perfect. Thank you.
Yeah, no worries.
Okay, Kevin, we have a couple questions that are in the chat now.
Okay.
The first one is from Paul. So how was this decision made to move into step code 4 so quickly?
So the BCBC are in consultation with municipalities and other stakeholders. And as noted, their 2022 proposed updates are going to include a step 3 minimum baseline. So come 2022 BCBC, basically effective December of 2022, there will be no step 1, step 2. Step 3 will be the baseline. It'll be the baseline minimum. So that's basically the BCBC bare minimum. The township, as noted, has been a leader in step code implementation, and we have elevated requirements for energy, GHG emissions, and all things sustainability. So in line with our expectations, we are elevating our step 4 requirement, part 9 requirement to step 4 to be aligned with being ahead of the curve.
Okay, thanks, Kevin. We have one more question right now in the chat. So this is from Lynn, and they say, we know we will move to step 4. I believe they meant trades. So did the trades have any training to prepare going into step 4 and then from material to installation? So I guess, did trades have training to go into step 4?
Did the trades have training to, well, the Township of Langley has adopted step code in January of 2019 and begun consultation probably 2018 to notify industry that we're going to start step codes. So industry has had since about that time to kind of mobilize, start training, and the Builder Forum series as well supported that transition. So there has been at this point 4 to 5 years to learn what needs to be done, what changes in practice need to be made. There's a lot of support, a lot of resources out there, not only from the Township of Langley, but BC Housing, BC Hydro, etc., to support changing practice. So there has been a fair amount of resources to support a full spectrum of people involved in the design and construction of a building.
Thanks, Kevin. So we have, it's 9:31. We just have one more question in the chat right now.
Okay.
So from Andrew, he asks, will most houses today built at step 3 meet step 4 if the air changes were at 1.5?
Yeah, that's a great question. Yes and no. There's, I think, maybe Dallas can just, when we're, during your lecture, Dallas, maybe you might be able to be more equipped to answer that. So to answer the question, it's yes and no. It really depends on some other energy-based factors. If your airtightness will impact your energy performance, but that does not necessarily mean you'll kind of elevate your step right off the bat. But at the same time, it could totally be a home run for you if your airtightness is very, very high, and just kind of slip you right into the next or elevated step. But Dallas works on this on the daily. So maybe with that being said, that's if there's nothing else pouring into the chat box or no hands up, maybe that's a great segue into Dallas's lecture.
Yeah, I think we're good to go.
good?
I don't see any hands up. And yeah, if I believe if you have more feedback or comments on the proposed upcoming changes, then you can email greenbuildings@tol.ca. Is that right, Kevin?
Yeah, that's absolutely right. And thanks for noting that, Sarah. So if there's other questions, as noted that quite early on the presentation, I provided a number of different avenues for feedback and comments. Please choose one of those to provide your feedback. We do want your feedback. Okay, well, that all being said, and thank you very, very much for your comments, questions, and feedback. Let's move on to our educational portion of the day. I'd like to introduce Dallas Hordichuk of Bernhardt Contracting, and today's lecture is on Part 9 in the upper steps. This is a builder-to-builder training. Dallas, he works out in the field. He is a builder. He's also a modeler and probably wears a number of hats. But he's out there. He knows what works. He knows what doesn't work. He's felt the pains of maybe trialing certain strategies or materials, and he's here to share that with you today, so you can learn from his experience to transition into the upper steps all that easier. He's going to show us some tested methods, meeting the upper steps, lessons learned, best practices, and all that good stuff. And as well, this is consulting to you, so please ask questions. Dallas is here for the next hour and a half, so please put your questions in the chat. There may be a Q&A slide where you can do a voice question, but please take advantage of Dallas's experience. With that being said, Dallas, you can take over and share your screen.
Great. Let me just get off this screen. Sorry, give me 1 second here, get it all set up. Just want to make sure I can see the chat. Hello, everybody. Welcome to Step Code Learning. Fun times, right? So today, I just want to, sorry, gotta click on a few different things here. There we go. Today, just want to kind of give a quick schedule and a quick overview of what we're going to talk about. We're going to go over basic step code review. I know most of you are, sounds like you're already at step 3, so a lot of this should be a little bit of review for you. I want to focus this particular presentation on the struggles that builders have in the higher steps of step code, which is going to talk, we're going to talk about most common systems for cost-effective step 4 or 5, and we're going to talk about beyond step 5. We're going to talk about net zero certification and low carbon construction. Quick introduction to myself. My name's Dallas. I'm a red seal carpenter. If you don't know who we are, or we were a passive house builder, kind of pioneered it here in North America. I was project manager for Bernhardt Contracting on a number of projects. I'm also a certified energy advisor with, as you can see, basically every certification that comes under that umbrella. Just want to put this out here as I'm giving the presentation. I'm not on a script. I would love to hear questions, comments, feedback. I like to create engagement because quite often I find that in these types of talks, if we can create engagement, really good ideas come out of this, because I realize builders are really smart people that have sometimes struggle with some of these things, but most of the good ideas that I've been able to kind of mine from this have come out of sessions like this from people who've had problems, and then we can kind of consult and talk together on ideas. That's a great question. We'll get into what net zero certification is later in the presentation, Wally. But you'll start to see it coming down. As Kevin had said, the federal code that is coming down is trying to align with net zero by, I can't remember, is it 2030, 2035? They kind of shift the date around a little bit. But yeah, we'll get to that. So, as everybody knows, there's 3 areas for step code. It's a bit of a dance that we're playing between these three metrics, right? We've got airtightness metric, building envelope metric, mechanical metric. And within those, we've got some percent better metrics that we're going to be able to utilize, which we'll touch later in the presentation here. You can ignore the numbers here. Don't worry about it. That's for your energy advisor and your design team to deal with. As builders, there's other things that are more pertinent to us that are going to matter. But there are 2 either or categories, and I don't have this in here, but I there is a proposal for some either or with the airtightness targets coming down that I just found out about a couple of days ago. But I can't say for sure whether they're going to be in, but there is potential. So from my understanding, really small houses are having problems with airtightness targets, but we'll get into that. So talk about absolute metrics, fun times. Teddy, the thermal energy demand intensity. What we're looking at here, the biggest thing that affects Teddy is the geometry, insulation, and the windows of this house. And the geometry is the #1 factor in this case. This is something that we deal with in design. So Teddy's not really something, it's really easy to predict. It's not something that we typically see fails on. As long as once you get your compliance form from your energy advisor, as long as you follow what that compliance form says, you're good to go. Just don't divert from the compliance form. Page 1 of your compliance form, that's what's going to dictate your minimum code for your house. So our Teddy targets, what we're seeing is step 3 in most locations, and our 22 bats with a 2x6 at 16 inch on center is our most common for step 4 that we're seeing at the moment. So we're not really seeing exterior insulation at this phase. Even at some of the step 5 stuff, depending on the build, the geometry and window orientation that you have, we're not seeing a ton of exterior insulation there. Our 22 bats are what we're seeing, which is probably what most of you are already building. So as far as Teddy is concerned, the jump from step 3 to step 4, like that, I can't remember, was it Andrew? I can't remember who was saying, yeah, Andrew, I see your comment here. You're probably doing mostly R22 bat or R22 bats. If you're not, you're doing R20 bats. You're not changing your wall system. You're just changing the bat that's going in the wall. So pretty easy step forward for you as far as Teddy is concerned. Right? Sorry. There you go. R22 on both of them. So most common wall system for step 5, we're just spacing. We're doing some spacing of our studs to give a little bit less thermal bridging, give a little bit higher effective R value on our wall systems. So once again, we're not changing a whole lot. And in fact, in a lot of ways, I would argue that we're saving money because we are saving material. And as everybody knows, material pricing has gone insane over the last little while. So if we can space, now this is gonna be contingent on engineering requirements. I realize that. So I'm on board. Our 24 spacing, this is what we're seeing for most of our builds in step 5 in our region, which is the same climate zone as Langley. So this is what we're seeing for step 3 and step 4 as far as our window requirements are concerned. U1.5, 0.3 solar heat gain coefficients. Pretty straightforward windows. These are Home Depot off-the-shelf windows as far as what we're seeing for window requirements. Not super high. Yeah, that photo there you're seeing is pretty gnarly window. That's actually in Mark's personal house. But we're not seeing insane window requirements. We're seeing basically a transition from doing what you're doing now to doing the same for step 4. This is what we're seeing for step 5 requirements. Slight increase in window performance, not a whole lot. As we're going into colder climate zones, the windows start to become more of a factor. So 1.2, you can find a double pane window in 1.2, but as we're shifting into climate zone 5, U1.2 is you're probably looking at a triple pane window there. So you could be flirting with the line at step 5, but that's what we're seeing. We get a ton of questions from builders on window details as far as step 4 and step 5. They're like, do I have to change my window detail? What do we got to do for step 4 and step 5? I think it boils down to this. Is your window leaking water? If it is, just do a better job. If it isn't, then you're probably good all the way to step 5. That's it. So you don't have to change your window details, what you're doing. As long as you're sealing your windows, air sealing your windows, you're good to go. So this is something you'll hear if you've ever seen Mark or I give a presentation. The Teddy, this is the biggest struggle that we see with the Teddy is complicated building shapes with minimum code assemblies. It's not to say that you can't build this. You absolutely can. It's just this is where we're going to see cost increases in the higher ends of step code is if you have complicated building geometry or bad window position, right? So if we have lots of north-facing glazing, we don't have free solar energy to capture from the sun. We have just thermal loss, and everybody knows that the windows are the weak point in the thermal envelope of the building. So where we're really seeing a problem with it is when we couple the two together. So, and once again, it's not to say that you can't build this way. It's just you're going to have to make sure that you adjust your pricing for some allowances with these types of homes. You can, with step code, you can basically build whatever you want, but the cost factor comes in when we're starting to deal with very complicated building geometry and poor window placement. The graph you're seeing here on the right, I know it's not super clear, but these are basically the steps. This is this particular house. We developed some step code automation software that can throw a bunch of different assemblies at the house. And incidentally, 864 combinations in this particular house with complicated building geometry and north-facing glazing couldn't get this house out of step 1. So it's just something to be aware of, which I'm sure you already are if you're already building to step 3. It's just, I want to put this on the table that as this becomes exacerbated as we start looking at the higher ends of step code. And surface area is more important than insulation. So these are two houses that we looked at. You can see here, one has a little bit more complicated building geometry, one a little bit less, same solar orientation with them. What we did is we took them and we threw the same amount of with the exact same assemblies. This house only has a few assemblies that can sneak it into step 4. This one's well into step 5, just based on building geometry alone. So there's diminishing returns on insulation. It's really difficult to insulate your way to success in step code. Or you can, it just gets very expensive. That's all, which is fine. So MUI, mechanical systems. Basically what the mechanical systems are is they're affected by what type of mechanical system you put in your house, but it's also affected by your TEDI. So if we can insulate the house, that means that we have to heat the house less, right? So this house, yeah, this mechanical room is pretty crazy mechanical room you're looking at. This is a house that I did some HRV installs in. This was one of the most insane mechanical rooms I've ever seen. It was a 1,200 square foot mechanical room, and it was packed with mechanical systems. Crazy house here. So fuel choice and step code. We're looking at step code is fuel neutral, but physics is not. What we're looking at is kilowatts of energy in versus kilowatts of heat out. So furnaces, we're looking at about, I think 96% efficient is probably what most people are installing now. So we're getting, for the 1 kilowatt of electricity that we're putting and energy that we're putting in, we're getting 0.96 kilowatts of heat out. Electric baseboard heat, we're putting 1 kilowatt in, 1 kilowatt out. A heat pump, we're putting 1 kilowatt in, 2 to 3 kilowatts out. We'll talk about pricing because I know it always comes up in these situations. So we'll talk about that as time moves forward here. Step 5 heating systems, heat pumps. That's what we're seeing. We're seeing heat pumps everywhere at step 5. Cheapest running cost. We don't need a backup. We don't need gas backup. You can if you want. I would just argue that you're spending more money for something that's kind of redundant. You're installing redundant heating systems. You have access to cooling, which gives us some climate mitigation. I don't know what the temperature was in Langley. It was 34 degrees here in the city of Victoria. The last couple of days is quite warm. So this is something that we're going to start seeing more and more as we're moving forward, is that with climate resiliency and comfort of homes, we're going to want to start putting in cooling. And then an air conditioning unit is a heat pump. So I would argue that if you're putting an AC unit in, you just put a heat pump in for the little bit of extra money that it is, because you're already installing a heat pump. We're seeing them, companies are coming out with them. You can use them in radiant systems. Sandent makes a heat pump hot water system that you can use in a radiant floor heating system that is a combi system, or you can use it in forced air. Or if you're doing it now, you're probably doing a forced air central system or mini splits. I'm not going to touch too much on the specifics of heat pumps, but heat pumps are the way we're moving. We're electrifying heating systems at the higher ends of step code. So we're looking at cost of operation, including install costs, amortized over a 25-year lifespan here. What we're looking at, these are using Fortis's numbers, the gas, we're looking at renewable natural gas versus electric. amortized over the 25 years. These are the costs that we're looking at. And so electric systems are cheaper in the long run to operate. So we're looking at RNG here. Quite often we're like, oh, what about regular gas? Because RNG is quite a bit more expensive. When we cost adjust for efficiency, this is what we're seeing. We're seeing gas at about 5 cents a kilowatt hour. We're seeing renewable at about 8 cents. Electric resistance is a baseboard heater, 12 cents a kilowatt hour. Once we start getting into heat pumps, especially reasonable heat pumps, we're quite a bit cheaper on our operational cost than gas. The electricity, we had to use a blended rate because everybody lives in different tiers of electricity. So we decided to use a blended rate. Yeah, so Darcy, good point. We don't know what electricity will cost in 25 years. So what we did here is we took Fortis's numbers. We took the gas utilities numbers on this. So we didn't use BC Hydro's numbers. We used the gas utilities numbers. We also don't know what gas is going to cost. And from my understanding, as carbon tax increases, gas is looking to double in cost in the next little while. I don't know. How can we extrapolate? I'm not entirely sure. So what we decided to use is we decided to use the gas utilities cost on this. We decided to use their numbers. So sizing heating systems. This is something that we're seeing, that we're starting to see become a really big problem. So what we're looking to do here is we're looking to properly size heating systems using a room-by-room heat loss calculation. So if you're looking at applying for, we'll talk about net zero heating systems are required to be what's called F280 heat loss size. And if you're applying for rebates from BC Hydro, quite often they require them to be, yeah, great, thanks, Kevin. Quite often they also require them to be sized properly. So what we're seeing in mechanical contractors who don't do these types of calculations is that they're oversizing heating systems. And the reason for that, I don't know for sure, is that the mechanical contractor will get a call back if there's not enough heat in the house. They'll never get a call back if there's too little, or sorry, if there's too much heat, they won't get a call back. But that has energy implications. So when we do these heat loss systems, this is a real world example of a house. And so the size of this system is about 1100 BTUs per hour is what it's saying. The size of the system that went into this, that the mechanical contractor put in, was 36,000 BTUs. And incidentally, they decided to put 2 of them in. And so they oversized this system by 5.6 times. So this is another cost savings. So for us, it's about a few $100s to do this calculation. Our company, if your mechanical contractor can do this, great, let them do it. But you're definitely going to want to size these heating systems through a room-by-room heat loss calculation. So because the heat pump is designed to run like this graph on the left, it's designed to run constantly for a long time. When we're seeing thermal cycling, when we're seeing cycling like this, we're using more energy. The spikes are what is going to use more energy. So when we see people say that heat pumps cost more to operate than gas systems, quite often they're sized improperly, and we're seeing these spikes in energy. And so definitely, if we don't size the heating systems, they're certainly going to be more expensive to use because they're going to use significantly more energy. So size your heating systems. That's the take on this. Spend a few $100s, size them, and quite often you'll be saving yourself money because the cost differential between a 40,000 BTU system or a 15,000 BTU system is significant. Heat pump operation, all right, like I said, should run for a long time and for often. Low and slow, that's what you need it to do. Don't use large setbacks or turn them off at night. Let them run. That's what they're designed to do. Hot water systems at step 5. Electric tanks are the #1 system we see. Just your conventional electric tank. Cheap running cost, cheap install cost, low maintenance, and it's got a longer lifespan than boilers do. It's really that simple. This is the #1 heating or the hot water system that we see. On occasion, we see heat pump domestic hot water systems, particularly when we fit them in with combi systems. But the location of where you put them is important. It will cool the room if you're not using an if you're not using an outdoor condenser on them. So putting them, just think about where you put them, because it's definitely going to cool the room. They are quite expensive to install right now. The cost will come down over time, I would assume, but they can be integrated into a combi system. Or if you have a client that wants in-floor heating, this is a way that you can do it at high ends of step code. Kevin, got your hand raised.
Thanks, Dallas. I'm curious, do you know about recovery rates for these heat pump domestic hot water heaters? Are they similar to a gas or electric, or are they, you can't take a consecutive baths?
Are you talking like an efficiency rate?
No, like a recovery. So if I use, X%, like I empty the tank after, some dishwashing and bathing, one of the kind of feedback or questions I've been hearing from industry is, there's a fear of recovery. So how quickly can it heat back up, that volume of water to continue doing whatever domestic needs?
Yeah, so I would argue that as we reduce the energy requirements on the home, that recovery rate becomes kind of moot, because if we're putting them in conventional homes that have no energy requirements on them, that are losing heat significantly, that's where we're starting to see that. So in a conventional home retrofit situations where those recovery systems, once again, we have to size them. So if we size them with an F280 heat loss calculation, they will be sized properly. So that would be my take on it. We haven't really heard any of our contractors complaining about that. So I'm wondering if they are sized improperly. That might be my question, is how did they size the heating system, depending on what they're using that for. Not to say, so at step 4, quite often we're still seeing gas boilers as far as water heating systems. We're still seeing it there. If you've got great building geometry, you might even be able to sneak it in at step 5 right now. So it's not to say that you can't use them. They can absolutely be there. This is just what we're seeing most people put in our modeling that we have coming down the pipe. Does that kind of answer your question?
I was asking about more domestic needs, like just for domestic hot water use. So
right.
that would, and I don't have any experience with these, so I'm curious about what people are experiencing out in the wild, as that was the first time I heard that. There's a fear of, how quickly, how powerful could this are these condensers, and how much heat can they generate?
See.
After somebody takes a bath downstairs and the in-laws to do this, and you're doing the dishes, and then now it's baby's time for a bath and there's no hot water and you got to wait. The fear is you have to wait a long time. That's right. That's what I'm asking about. Yeah. Right.
We haven't had any of those problems. We've actually put heat pump domestic hot water systems in all of our passive houses as well. And we're lucky. A bunch of our clients allowed us to monitor those systems over a period of time, because we had been in the passive house world quite early. And we wanted to test these homes over a period of time, because we figured that was important, because we wanted some data and we had no problems with it. Now, with that being said, everybody's mileage may vary. If you've got a house of 20 people and you put a single hot water tank in, yeah, I mean, you're definitely going to have those problems, right? So at that point, consider maybe a second tank, depending on the use. Building code the way we look at building code and the way we operate houses are a little bit different, and building code can't always predict the way that you're going to operate your house. So I would say that we're going to want to think about the way that we're actually going to operate those homes, because building code sometimes can't really, they're kind of two different ways of looking at it. Yeah. Or Wally says, put in a larger tank. Absolutely. There's tons of different sizing of tanks that you can put in. Absolutely. You can just put in a bigger tank. So that's the other thing. There's a bunch of different sizes of tanks you could put in. Kyle, so Kevin, is that better for it?
Yes, thank you.
Great. Yeah, thanks, Wally. So Kyle says, how would a hybrid heat pump hot water compare to an electric hot water tank? Heat recovery with a heat recovery device. So I'm gonna touch on HRVs in a little bit, if that's what you're talking about as for a heat recovery device, or are you talking about a domestic hot water recovery system, Kyle? Because there's two, I don't know if you're talking about ventilation heat recovery, or if you're talking about domestic hot water heat recovery. Yeah, domestic hot water heat recovery. We actually don't see a lot of domestic hot water heat recovery systems. I know Einar spoke. I know he likes them a lot. He puts them in, he suggests them quite a bit. We don't see a ton of them in their homes, so I can't speak to that, unfortunately. Maybe email Einar. He might have some ideas on that, but we don't see them very often. Our builders that we don't see them in our homes very often. So unfortunately, Kyle, sorry, I can't say. I would suspect if we're looking at it from an efficiency standpoint, the domestic heat, the heat pump hot water system would come out ahead. In actual operation, I don't know. It's tough to say. Sorry, I wish I could answer your question with it more definitively, but I'm not entirely sure how they compare. We haven't done any real analysis on that. Interesting thought though. I might have to take a look at that. I never really thought about that before. It's a good way to look at it. Great. So more mechanical systems. So I got to step over here. Jerome, with building code perspective, that gets a little more complicated. And we'll actually touch on that as well. So appliances aren't going to be required to be all electric. Right now, luxury loads are unregulated. So gas stovetop, for example, is not really considered in the energy modeling of homes right now, particularly in the Part 9 world at least. I don't know about the Part 3 world. So unfortunately, what the modeling does, because the way the ecosystem works, is we assign static base loads to a house. So all houses get static base loads. So that is going to be something maybe for your electrician to deal with. Unfortunately, the energy modeling portion of that is not really going to be able to take care of that. Let's keep in mind, energy modeling isn't a one-size-fits-all for everything. What it's going to do is going to predict the overall performance of the home. There's still going to be some little things that you're going to have to work with your sub-trades. And as Einar spoke earlier, if you're in his, I truly believe that the integrated design process is the way to do that. So just talking to your electrician, that's part of the integrated design process. Bringing them to the table before we start the install and be like, hey, what size service do we need to this house? Are all of our electrical loads going to be able to be accounted for in our panels and in our service? If the answer is yes, then you're good to go. You just did the integrated design process. That's what it is. So yeah, so hopefully that answers your question, Jerome. In-service energy use for these buildings. If so, how accurate modeled MUI when compared to the homeowner energy bills? Jason, this is actually, I want to be careful about how I speak about this, but the answer, I'll be completely open with you on this. The answer is that the energy performance of the home relative to what the actual energy use is, we can't say for sure. But building code is about being able to create a fair system for everybody. And the EnerGuide rating system is about comparing houses to each other, so that when we get an energy label, we're looking at how this home compared to this home, compares to this home, compared to a standard. So the way base loads work in a house is every single house, the occupant load is 2 adults in Part 9 single family homes. Multi-unit residential builds are a little bit different, but every house gets 2 adults, 1 child at home 50% of the time. Residential builds is each unit gets 2 adults at home 50% of the time. Now, that gets complicated because if we have a family living in a house at one point and then another single occupant living in the house at a different point, and then we renovate that house into a duplex and now 2 families are living in that house, it gets really complicated in how we predict the energy performance. So I don't necessarily think that step code is set up to predict your actual usage, and that's a little bit harder to do. The passive house system is a little bit better at that, but it's still not 100%. I don't really know that I've seen an entire energy modeling system that can predict the actual energy usage of the home, but I don't really know that they're designed to do that. So unfortunately, if you're relying on it to predict your bills, I wouldn't be doing that. So great, awesome questions. Thank you. HRVs. Yeah.
Yeah, and just to comment on Jason's question, I think that's a really important question that I think we're all kind of curious about. And another way to look at it is fuel ratings in cars. You know, the test that they and the methodology they have is standardized across the board, probably nationally, internationally, to get a sense of, you know, what's efficient, what's not, you know, a sports car versus a really compact fuel efficient car. But how you drive it, you know, your mileage may vary, so to speak. So the concept is, while, you know, two different homes with a similar rating may perform differently, it's not a measure against the methodology of design. It doesn't really speak to step code or the design methodology. It speaks to the occupant's behavior. So, well, that's a really important, and I think that's going to be a priority provincially, that with the concept of benchmarking as we move forward. And we're all very curious about it, but that's kind of another way to look at it. Oh, and yeah, there you go. So setting benchmarks are more important. Yeah, there you go.
Yeah, I think, yeah, I mean, keep in mind that this is probably going to evolve over time too, right? I mean, BC is setting the standard. Langley, going from step 3 to step 4, is trying to be ahead of it all, right? Which I think is great. So it probably will evolve over time, and you'll see there are the BC building code is so to speak to the mandated step 3 target. The date for that, as far as the province is set, is December 18th. That's the date. I mean, that might change. It absolutely might change, but that's the date that they've announced. So mark it in your calendars. If you're building outside of that region, get your building permit in before December 18th, then you're probably good to go. But as you continue to build houses, I would argue that this stuff really matters, and you're going to want to set up design requirements and set up your business to think forward, not to just scrape by, right? Because if you're just kind of scraping by and living behind the 8 ball all the time, that's where you're going to get frustrated. But if you can think ahead, think about these concepts, it's going to make your lives way easier. So HRVs, we get this question quite a bit. In your climate zone, you might be a little bit disappointed in the energy performance that it gives the home. But I would argue that AC, as the air exchange drops, the need for balanced ventilation increases. So as we tighten up these homes, mechanically ventilating them properly is a good idea. I would argue that ACH coupled with an HRV, maybe an ERV, if you feel like it. I think that in our region, an HRV is a better solution. It dumps humidity as opposed to recovering humidity. Those are basically the differences between the two systems. I would argue that ACH increases and HRVs are a single upgrade. That's what you're looking at in those homes. And as we see wildfires happen, HRVs can provide some climate resiliency in the form of air filtration. I just bought a condo here in the city of Victoria. And the reason why I bought it was because it has an ERV in it, and I can renovate air filtration into that ERV to give myself some wildfire climate resiliency as time moves forward. So, because that's not something that you can easily renovate into part 3 multifamily or part 9 multifamily, because dealing with stratas and building envelopes is very complicated. The other benefit, this is actually something that came up more recently, is our builders have told us that they're starting to see less screw pops and return on service work on their homes because they have higher humidity control in the home. So the humidity isn't causing the wood to do this and having screw pops come out over time. So when you're going back to do your 1-year walkthrough, they're starting to see less service work with it. Your mileage may vary on that as well. This is this is an anecdotal experience that 3 of our builders brought to the table independently of each other. So surprising, but it was there. So I figured I should include it. So yeah. So like I said, you might see, I guess, I don't know what the City of Langley's policy is on it, but what we're seeing in our region is if you're using conventional ventilation systems, bath fans or something like that, and we're seeing air exchange drops, and you have an unregulated luxury load like a gas fireplace in your house, then quite often they're going to start to require backdraft testing. And when we see backdraft testing, yeah, so if we start to see that we have, the way we do that is we go into the house, we turn on every single fan, all the bath fans, the range hood, everything. And then we have our manometer that you'll see in all your blower door tests. We throw a hose outside and we see the air pressure differential from the inside to outside. And if we see backdraft issues or potential for backdraft, quite often they're going to make you put in makeup air, which is a whisper grill, which is just a hole in your wall. Now you might have air exchange problems with this. An ERV, most of the ERVs have a setting in them where you can say that there's a fireplace in the house and they will deal with that. And then the letters that we write to the municipalities can often negate that, the requirement for that. So just be aware if you're like, I'm not going down the HRV pathway, I'm not putting it in, I don't want to do it. There are other implications that could happen down the road that could affect airtightness, which has potential to affect compliance. So just be aware that that is a problem that you might deal with. We don't see it all the time, but it is something that we see from time to time. So this is something that's coming down the pipe. It's kind of in the works right now, but there are some targets that have been set. Kevin, it sounds like you guys have some sort of greenhouse gas targets for your builds already. So it sounds like Langley's already ahead of the curve, but greenhouse gas intensity targets, there's some proposed provincial metrics for this. So
just to confirm,
here's the,
sorry, let me jump in here. Yeah, we don't have direct targets for a metric. We have elevated expectations around design that reduces your GHG consumption. However, we anticipate being in line with the province and using provincial tools to help standardize a reduction in GHGs.
Yeah, great. Yeah, so you're looking at a complicated bunch of tables here. Don't worry about what these numbers actually are. This is really what matters. So what we're looking at here is a database of about 1,500 files that we produced, and we sorted them by their mechanical systems. So green, you can see all electric, red is all gas, the two blues are a mix between the two. This is the target that's proposed for July 1st, 2023. And this is where these mechanical systems are falling. So it sounds like you guys are going to be step 4 already. So maybe this won't be a problem for you, but it is going to be something that you're going to have to consider when we're looking at, and this is going to run alongside the step code. So it's going to be step code plus GHGI targets. Sorry, Jason said, it's been so smooth for homeowners to adopt HRVs or ERVs. Has it been, sorry, from our experience, compared to if they were previously living in an old house? Do they ever shut it off due to noise? Are they changing filters enough? Okay, so let's deal with that from the top. When we're talking about comfort and climate resiliency, that's where we start to see homeowners really seeing the value of ERVs and HRVs. Those are the two things that they really start to care about because they can like quantify that in their lives, right? The energy implications are something that are a little bit harder for them to kind of see or feel or touch, but they remember what it's like to breathe in smoky air and they know what it's like to not. So that's kind of the way we've been kind of pushing it. So the answer is yes. Do they ever shut them off due to noise? Definitely. But for ours, the biggest complaint that we get, the biggest callback that we get from them is when we're doing more high performance HRVs, they think they're not on, they're not noisy. They call us back and they're like, this machine's not running. You need to come check it out. And we show up and sure enough, it's running. So, and are they changing filters enough? There's a bit of, it depends on where they live as to what's going on, as to how often they're required to change the filters. So because we do a lot of them, we made a video for all of our, like a how-to video that we send to all of our clients, basically. Yeah, so most of them are changing filters enough. If you've got construction going on in your neighborhood, you're probably gonna have to change your filters maybe every 3 months, maybe, right? If you don't and you live in a remote area, then you probably have to check them once a year, maybe change them, maybe not. So it depends where the house is being installed, where the house is, as to whether they're changing the filters and how often they need to change the filters. So I don't know. But yeah, and I would actually argue that what you're going to want to do with your mechanical system is do an integrated design meeting with your mechanical people, because HRVs are not a small system. They take up a little bit of space. So you're going to want to plan some routing for them. That's another thing that you're going to want to do, because where those diffusers are, so that is where the air comes into the room, and how you get from the machine to that diffuser, that takes a little bit of planning. IDP is 100% the way to go for that. The way we sequence it is framing goes in, HRV comes in, alongside plumbing rough in usually, electrical comes after that, because otherwise your electricians are going to chew up all of the space for your mechanical systems, and they can wrap their wires wherever they need to. The mechanical system and the HRV kind of has a set route and a set size that it needs, and a set area that it needs to take up. So that's how we sequence the install of those things. But so yeah, hopefully that answers your question, Jason. But this is coming down. July 1st, 2023 is the proposed metric. It's a year away right now, and this is what we're looking at. So we're going to be probably looking at all gas systems, which maybe you're seeing them at step 3. We're still actually seeing quite a bit of all gas systems in, but this is coming down the pipe. This is the other target that we're seeing, January 1st, 2025. We're looking at pretty much all electric. There might be a few that might squeak through, but the GHGI targets are coming. So our conversion factors for this were taken from the province, how they're going to implement this, but GHGI metrics are going to run alongside building code, and they're coming sooner than you think. So this is kind of the area that I really wanted to focus on here, because this is the one, ACH, as you probably all know, is the target that is something that we can't predict as easy as all of the other ones, because it basically has to do with the quality of the install that we're doing. And as Einar said, it sounds like Einar said, there is no one building or one, air barrier trade. They kind of all are air barrier trades, actually. As your electrician punches through your air barrier, they're an air barrier trade. The installer, who might be your framing crew, they might be your in-house crew, they might be your insulator, they're also the air barrier trade. The plumber who's going through your air barrier, they're also the air barrier trade. So they're all kind of air barrier trades. Quality control on this is going to be critical to your success. But what we are seeing is that most of our tests are passing the intended target. 90% of them are. And the reason why we're seeing that is we're doing mid-construction testing. We're coming out when the air barrier is exposed, whatever you're using for an air barrier, whether it's an exterior Tyvek, whether it's a high-performance SIGA or Intello membrane, or whether it's a conventional poly membrane. It's still exposed. We test it while it's exposed so we can fix it if we have problems with it. And as we start to do that, I'm sure you all know, you start to see the areas that are regular problems, right? Inside corners, transition things, plugs, pot lights. Pot lights are the leakiest ones that we see all the time. There's tons of areas where we're coming in and out of the air barrier where we see air leakage. And so the most common one that we're starting to see now is exterior sealed membranes. So Tyvek can be an air barrier if you seal it. You can have multiple air barriers in your wall, but you can only have one vapor barrier. And the vapor barrier in our climate zone, as far as BC is concerned right now, is on the warm side of the dew point, which is why we put it right next to our drywall. The reason why air barriers fail is lack of supervision and sloppy work. It's pretty much every time that's why we see them fail. A big one, just supervise your sub trades. Unfortunately, that's what you have to do. This is a photo you're seeing here. This is a landing of a set of stairs on the inside of the house. The framers in this case knew enough to pre-strip, in this case, the air vapor barrier behind it, but not enough to know that they shouldn't post out and slam into the stud here, because I don't know how they're going to seal this membrane now. It's going to be really difficult for them to do that. So I would argue these framers, they were actually really great. They just kind of lacked a fundamental understanding of continuity of air barriers, of the air barrier being continuous and how we're required to seal it. Spray foam, always a controversial topic. the majority of fails that we see are on spray foam houses. This is a number of reasons for this. Spray foam is actually a bad building science assembly. It expands and contracts at a different rate than wood does. It has a mechanical adhesion to wood, not a chemical adhesion. So as your wood does this from humidity and temperature change, the spray foam cracks off. It creates little micro gaps in it. You can see here, what you're seeing here is spray foam installed and then a thermal image of us negatively pressuring this house and sucking cold air into the house. So the cold spot here is an air leakage point in this. If you have I-joists as your flooring system and you're spraying in your joist ends, as it expands, it quite often doesn't get into all of those little corners that you need to, and then it's death by 1,000 knife cuts. Should EAs be promoting more external air barriers? Why do more builders not use plywood as an air barrier and tape the joints? Yeah, great question. Andrew, there's a million different ways to skin this cat. We've done taped plywood, we've done exterior membranes. Not all EAs, everybody kind of has their own preferred method, I suppose. We're here trying to promote exterior air barriers because I think they're easier to do. My background is I come from Saskatchewan from a tract background, builder that built over 150 houses a year as a site supervisor. So we did a ton of houses. And then when I moved into the high performance building world, and the first house that I did an exterior air barrier on, I couldn't believe how much easier the detailing was. It was way easier. I was blown away. So now moving forward, that's the direction we try and take it all in because it was way easier for me. Once again, your mileage may vary on that. If you have articulated intersecting roofs or really complicated building geometry, that might change. So there's going to be a little bit of you're going to have to kind of do your own diligence and kind of make your own calls on how you want to do that. But I think that EA should be promoting exterior air barriers. Spray foam does not meet the characteristics of an air barrier, 2-pound closed cell products. Depends on the product, depends on the testing. Even if it does, what we're seeing is that it fails regardless. And on top of that, we'll get into this as time goes later in the presentation, but it's got other bigger implications to it as well. It might not. It's going to be up to your engineer, your architect, you to decide what that is, the testing on it. If you're putting spray foam in, quite often we want to see what spray foam it is, and we need the spec requirements on that for insulation and for the air barrier requirements. If it's blocking air, it's blocking air. Great. But over time, this is going to be, it will crack off over time. Spray foam is marketed as high R value per inch and a vapor barrier, and it is those things. But as it cracks off, or if it creates pockets in the install, it's going to have a potential for water to condense and then not be able to get out. And then what that's going to do is rot your building assembly. And we don't do it because we put a 10-year warranty on our houses and we're worried about that type of stuff. Yeah, Wally's right. Every batch of spray foam is different. But yeah, spray foam, the point here being that spray foam as an air barrier, particularly as a primary air barrier for the majority of the house, is where we're seeing a lot of our fails. How to pass ACH every time? There you go, Andrew. Make construction tests every time. Avoid pot lights and poly boots, or come up with you'll have to come up with different detailing for them. Don't use spray foam. Exterior air barriers. So step 5 house that we built up in actually Coastal Custom Homes built. We did the consulting on it up in Courtney Comox. You can see the requirements, the building envelope requirements here for the step 5 house. Those are U1.5 windows, 2x6 at 16 on center R22 walls, ICF foundation, just a low-cost domestic hot water tank, low-cost heat pump, low-cost HRV. We could have played with those building assemblies a little bit, but we decided to go in this direction. This house was step 5, about 10 grand cheaper than every single other house on this block. This builder built every house in this development. And after they built this house, this is how they build houses every single time now. This is the direction that they fully moved. So they're consistently building step 5 houses This is a step 5 house that we wanted to cost optimize and make as cheap as possible. And the way that we did this, the pathway to this, was integrated design process. I know Einar harps on it. I harp on it. It is the only way that we can hit these high performance targets for reasonable pricing. If we all live in our own little silos, we can do it. It's just going to cost us a little more money and change orders down the road. So this is a real world step 5 house that we completed in 2019. Coming up, so you're probably used to seeing percent better metrics, the percent Teddy metric and the percent MUI metric right now. But these metrics are going to change in 2018 to align with the National Building Code. So we're going to touch on those a little bit here. So we're going to talk about the reference house here. So in theory, what it is, you're comparing your house to a code-built version of it, and then you compare the improvement between the two. What's actually happening here, we've deconstructed this, tried to figure it out as best we could, because we're trying to create automated pathways of whether you should take the reference pathway or the absolute pathway. And the reference house is a bit unpredictable. So what I would say is use it when it's there, but don't set up your business to rely on reference metrics because it's very, very unpredictable. The absolute metrics, you can predict them. They're easy. We can understand them. We have good fundamental understandings of them, and they actually lead to reduction in energy. The percent better metrics are a little bit of a, who knows what's going on. We kind of use it as like, all right, we didn't hit our absolute targets. Should we be looking at the percent better metrics now? So it's going to get a little numbery here. I'll try and fire through it a little bit, like relatively quick, but we'll get through it here. So the reference house will move your windows around. So if you have a house this way with your majority of your glazing facing north, this is what the reference house is going to do to your houses. It's going to move the windows around. I don't really know why exactly, but so now we're comparing this house to a house with south facing glazing in the reference house. So your house is going to not perform very well in this case. You have lots of north facing glazing. The reference house is not your friend. If we have this, it's a maybe. Don't really know what's going to happen. Maybe it'll perform better. Maybe it won't. I don't know. If we've got south facing glazing, the reference house is going to have north facing glazing, and it's going to, our house will appear to perform significantly better than the reference house. So this is it in real life. We've got a lake. Everybody wants to face the lake. Everybody wants all their windows to face the lake. Up is north in this case. The house with the north facing glazing in this case is going to be disadvantaged by the reference metrics. So you're going to want to use, you're going to have to use the absolute metrics here. The house that's facing south is going to be advantaged. Cooling load come into this. Anton, unfortunately, right now, there was a peak cooling load metric that came in. A friend and I did some analysis on the peak cooling load metric, and I'm going to be careful about how I talk about it. We couldn't reproduce the results that the federal government said that they were going to do. And in fact, in a lot of ways, we saw a lot of scenarios where it had very, very high absolute cooling load metrics, and the peak cooling load metric gave it a pass. So right now, that's something that's being worked on. Yeah, we were seeing cooling cooling loads that were like had potential to kill people. Like it was crazy, and the peak cooling load metric was like, yeah, it's good to go. And we're like, I don't know about this. So right now, there are no cooling load metrics. The only way that a cooling load metric plays into this is if you add cooling to a house, the MUI will adjust to allow you to burn a little bit more energy, which makes sense, right? Because now you're adding an additional load on the house. So they're like, okay, we're going to give you an allowance for that cooling load. That's the only time that the cooling load plays into it. Yeah, lots of overheating. Yeah, absolutely we are. We definitely are, for sure. So right now it's out of the scope of the modeling, which is really unfortunate. We're trying to work on that. Box and Joyce, Jerome, if you're using bat insulation in your walls, bat it, go to an exterior air barrier, done. That's what we're doing. So you avoid the detailing when you move it to the outside. So that's the best way to do it. Yeah. Yeah, and like Kevin said, passive solar shading is key for sure. Actually, I'm just going to bump back to this slide. On the backside of this house, I believe is southwest. The majority of the glazing on this house is southwest. We've got big sliders on this side, but incidentally, because we knew the design implications, there's overhangs on the backside of this house that you see. So that in the wintertime, as that sun drops, we're capturing solar energy from it. But as it rises in the summertime, we're getting full solar shading on those homes so that we don't overheat it. Yeah, absolutely, Kevin. Yeah, great point. So percent better metrics. This is what we're looking at. If you're facing south, articulated house with south facing glazing, the percent better metrics are going to favor you. If you're facing north, if you're glazing, the majority of your glazing is facing north, you're sticking with the absolute metrics. So that's what we're looking at here. When to use them, you have a south facing lot, you have a big budget because those seem to be the ones that favor the percent better metrics. And in a highly articulated building with number 1 and number 2, that's the time you're going to be using the percent better metrics. So do not set up your design requirements to rely on these metrics. They're very, very difficult to predict, but definitely utilize them when they're there, we use them all the time. Yeah, in all other cases, you're better off the absolute. So there's a question about net zero. So net zero is going to fall between step 3 and 4 sometimes as far as the building envelope assembly requirements and the actual requirements are. But what the goal of net zero and net zero ready is to prep for your on-site renewables. It's to get design loads down. What we want to do is we want to get those loads down as much as we can so that we can use solar, renewable solar or renewables, on-site renewables, sorry, in ways that make sense, right? So this was a net zero heritage house that we were a part of. This probably looks similar to houses that you guys see in Langley, a little bit of articulation. But what we're looking at doing here is we want to lower those energy loads first. So we're looking at pre-reno and then our post-reno. So our post-reno in this house, before we started sizing solar systems, is we are looking at reducing the energy loads, not just offsetting them. And then once we get the energy loads to a reasonable amount, then we will offset them with on-site renewables. So net zero is a certification that you can get through the CHBA. It sounds like some of your builders are already doing it, that are going to model out so that overall, the modeling will predict that overall the house will consume 0 gigajoules per year. That's what net zero is. Net zero ready is there's enough space on your panel for your solar system, and you have the infrastructure in place to just install solar panels. You don't have to do any deep energy retrofits. It's ready to go. The modeling's already done for it. You just haven't installed the panels yet. So those are the difference between the two. So net zero, modeled out to 0 gigajoules. Net zero ready is everything's ready to go. You just haven't installed the panels yet. So when we're looking at going on beyond step 5, these are kind of this is kind of what we're looking at here. We're looking at electrifying your mechanical systems. Industry, yeah, passive design, yeah, great, yeah, perfect, yeah. We're moving in electrification. That's the direction we're going in. We see it not just with the step code requirements, but also with the GHGI requirements that are coming in. It seems like you can still see that there are some, if you've got good building geometry, it's looking like we can still see some gas systems in there. It's not saying that they're exempt from it. They can still get in there. Yeah, stronger roof for solar panels. Maybe. I'm not, so I want to put this out there. I'm not an engineer, so I can't say this for sure. But in the retrofit situations that we've been seeing, as long as you keep the solar panels at the same pitch of the roof, the engineers are typically okay with it. As soon as you shift it, wind loads change, all of these other loads change, then we have to start looking at stronger roofs. But as long as we're installing them at the same pitch as the roof, it doesn't, at least as far as my anecdotal experience, I want to be very clear, I'm not an engineer. We haven't been seeing any additional, requirements on roofs. Electrical heating, which owners may not be wanting. So in new build, gas systems still require electricity to operate. They're all spark ignition. There's no what's it called, pilot systems anymore. So the gas systems still require electrical systems. If we're talking about generator backup, that's a different story. It's not really within the scope of building code. So yeah, absolutely, Laura, you're right. There's a solar installer that used to work for us. I'll deal with these one at a time here. I love this. This is great. So Laura, so yeah, they do have to be installed at a certain angle. Talk to your solar installer. Funny enough, like obviously everybody's looking for optimal angles. So we do see a little bit of reduction in efficiency in panels. But some of them that they were saying is like you can add an extra 2 or 3 panels and it offsets the reduction in efficiency. But once again, your mileage may vary. Talk to your solar installer. I'm not a solar contractor. So once again, completely anecdotal. Solar shingles, Vasco, I've seen them. Super expensive. If you got budget for them, do it. They seem really cool. I don't know how it works as far as long-term resiliency within them, and if a shingle gives out, if you can replace it or not. I don't know how that works. You'll have to talk to the manufacturer on that. So yeah, I don't know. Through wall heat pumps, yeah. Are we talking about just the tiny little ones? Probably. I haven't seen too many of them installed, so I don't have any thoughts on it, unfortunately. They seem really interesting. I don't really know what their requirements are. So I don't know. We haven't seen a ton of them. Where I'd maybe see them being really valid is maybe in a high density duplex, triplex, quadplex renovation situation where maybe one client wants to do it. They're worried about noise complaints because of the strata thing. I don't know. Yeah, I don't know. Seem really cool. They seem new, so I don't know for sure. Gas fireplaces, still spark ignition. They still require electricity. Sometimes they have battery backups, I will say that, for heating. Once that happens, though, your ventilation systems turn off, so be a little bit worried about that. But I mean, people can do whatever they want. Yeah, Anton, solar hanging, thanks for the comment. Yeah, great. Yeah, battery packs for home. Yeah. So if we're looking at climate resiliency and we're looking at on-site renewables, yeah, battery systems are a great solution. Building code is starting to deal with that. They're saying that you can't put them inside houses anymore. The battery system is going to have to be outside. So typically we're seeing them in garages. So that's where we're seeing them put in. Questionnaire for would-be politicians. Yeah, I don't know. I got to be careful about my personal opinion on the way that housing should go. I'm not really here. I'm here to present information. I don't really have a question, but yeah, absolutely reach out to your politicians. Ask them about this type of stuff. I think it's great. I love these types of forums because, like I said, I love all the feedback from people. I like that people are like engaged in their community and care about the future of their community. I think that's really great, particularly in building. I think that's awesome. But yeah, beyond step 5, what we need to start focusing on is load. Once we start bringing those energy loads down, the embodied carbon in homes start to become a bigger piece of the pie. And when we start looking at concrete and foams, which are plastics, they're a huge portion of that embodied energy. And that comes down to design. Yeah, keep them coming. It's great. So stop using spray foam. The city of Victoria and it sounds like West Vancouver just implemented deconstruction bylaws for homes over 1960. Once that spray foam touches a building material, that building material is forever garbage when we tear that house down. That spray foam as well is also trash. All of that just goes into the landfill. We can never reuse that stuff ever again. So when we're looking at circular lifetime impacts of products, spray foam is the worst culprit. It's terrible. So, and as we established, bad building science assembly, it's great insulator, great vapor barrier, but provides other problems that it brings to the table. Yeah, great. Yeah, thanks, Katrina. Yeah, start deconstructing houses. If they're older, right now they're saying if they're older than 1960. So we've done both deconstruction and crunch and dump. Your costing may vary, but we're very dedicated. We had a team that was very dedicated to this. Yeah, what do we do with spray foam and renos? Landfill. Yeah, it all goes to landfill. All of it goes to landfill. Anything that goes in there, if you take it out, it's going to the landfill. We can't reuse it. So, and then eventually it's just going to end up as microplastics in water streams likely. So I don't know. I'm trying to advocate to get away from it. And actually I see it used in filling up little micro holes in, as we've got electrical penetrations going through top plates, things like that. I mean, I get it. It gets the job done, right? So where I see it being a real problem though, as a main insulator, that's really the issue here is as we're using it as a main insulator. I just don't want to pretend that it's going to fix all of our problems because as we start to look, embodied carbon is on the horizon. I've got a thing coming up here. The government, the federal government is looking at embodied carbon. It's probably 100 years away, but the conversation is starting to happen around embodied carbon. And then the last thing we can do is trying to find alternatives to what we're already doing. So cellulose insulation has a significantly lower embodied carbon. It's thought of as a carbon negative insulator instead of fiberglass. And it's cheaper than fiberglass, and we can insulate ceilings the same way. So it's an easy transition to just use cellulose as opposed to fiberglass. Yeah, vermiculite. Yeah, exactly. So yeah, I mean, incidentally, vermiculite's a great insulator, but yeah, it's got bigger health implications that are involved in it, right? Basements, if you suggest no spray foam to move away from plastics, bad insulation and walls that fail. Yeah, I would agree. Yeah, if we're looking, probably what happened in those, I'm wondering, I don't really know exactly what happened in there. Right now, foams are kind of the only solution below grade that we have. I fully admit that. We don't have any other solutions at the moment, at least cost-friendly ones. And I mean, we're in a housing affordability crisis right now. I get it. We have to make concessions. The point of this is to trying to inspire you to think, if you can design it away, design it away. So rather than doing a full ICF basement, if you could do a step foundation and frame out your other walls, that's better than doing a full ICF basement. So I fully admit I don't have any solutions for full undergrade foams or plastics. They don't really exist yet. But if you can design them away, that's one solution that I see. Tearing out bad insulated, I'm wondering what happened there. I would suspect that maybe a vapor trap happened in the wall or something like that. That isn't necessarily a problem of the bats, but a problem of the building science of how it got implemented. I don't know exactly what happened there, so it's tough for me to speak to that. Prolonging the addiction to burning fossil fuel by giving rebates. Yeah. Thanks, Wally. Yeah, that's just comment from them. Great. But yeah, embodied carbon calculations are on the horizon right now. The federal government's looking at tackling this. If you're looking at implementing it into your building practices, a bunch of builders here are already doing embodied carbon calculations, and architects are starting to do it as well. There's a few carbon calculators. Right now, I'll be totally honest with you, the carbon calculation, the carbon accounting in buildings is like all over the place. There's no real good standard for it yet. Everybody's trying to work on the problem, but it is coming down because right now, as far as we can understand, that the operational emissions are a huge piece of that pie. And in new build construction, it's low-hanging fruit. We can tackle it. It's something we can absolutely do. The embodied carbon emissions is something that the way we look at it, how we do the accounting is the debate that's happening right now. So I wouldn't say it's around the corner by any means, but it is on the horizon. So it's something that is being talked about in code circles at a federal and provincial level right now. So yeah, great. So I like to leave off with this final slide here. This was my first passive house that I ever built after coming to work with Bernhardt Contracting, that I built beginning to end. It's full pedal living building challenge, which is the full most stringent sustainability challenge, full passive house, which is like step 9.5 in the step code. And I actually didn't find it that difficult. So if you're worried about step code, don't worry, like it's gonna be fine. Focus on right now, like I said, my big takeaway from this is Teddy and Mui are easy to predict. Your air exchange is less easy to predict, and there's diminishing returns as we're moving forward. So the jump from 2.5 to 1.5 is easier than the jump from 1.5 to 1. So if you can be ahead of the curve to give yourself a little bit of breathing room, if you target 1 and do a really great job and you hit 1.1 and we're step 4, great. Now we can start moving forward. We're not worried about compliance. But if we're worried about squeaking across the line and we're like scrambling to do it, that's where we start to see problems. So my takeaway is think to the future, try and be better than when we're at now to give yourself a little bit of breathing room. So I don't have a Q&A slide, but I would say right now, I mean, it's been coming in the whole time, but yeah, if anybody has any, we're, yeah, about kind of right on track for time, I think, right, Kevin? About 15 minutes left. So we got about 15 minutes left. So if anybody has any questions, my role, like I said, is I've got on-site building experience. I actually do this stuff. I sit in the role of an energy advisor as well. And we sit in some code stuff as well. So if anybody has any questions on any of those things, I'm happy to facilitate.
Hi, Dallas. I got a question. If I can, I guess, just jump in the queue.
Yeah,
This is Anton from Centra Windows. Great presentation, by the way. Keep learning as much as I possibly can. I kind of have one is a bit more of a statement, and it kind of is just building on the solar heat gain issue. A common trend I see in energy compliance reports is a statement stating 0.25 or greater, 0.35 or greater, 0.4 or greater for solar heat gain coefficient. What scares me is the word greater. If we're incorporating cooling loads into calculations, the word greater could mean that the cooling calculation load may not be correct. Because you might say a 0.3 solar heat gain coefficient, but what actually might be supplied for the building is 0.4 or 0.5 when we go with high heat gain, low E coatings. So the term greater there needs to be eliminated from EAs in these designs. That's my one thing. And number 2 on that is if solar heat gain isn't being adjusted, the number 1 complaint we're getting with buildings is overheating. And if it's not being dealt with enough, the shading that's being put on buildings is insufficient to deal with overheating. So when we talk about north and south elevations, the recommendation for south elevations is low solar heat gain because of the overheating issues that we're seeing. So just want to put that out there. There's no need to sort of answer it now, but I've brought that up several times over the past couple of years that cooling loads need to be factored into this calculation more. So
yeah, but I agree. Sorry, go ahead.
Yeah. So yeah, and I think we can all agree upon that. I know the industry does agree upon it. But my actual question that's intriguing is early on in the presentation, you said that step 3, step 4, and step 5 could all use U1.5 windows.
Yep.
So in the current real life scenario that I'm seeing for projects we're doing work on, step 3 is about a 1.4 U value window. Step 4 is about 1.2 to 1.0, and step 5 is 1.0 to 0.8. I have never ever seen a situation where a 1.5 window could be used for step 3, 4, and 5. But I do like the fact that you brought it up, because when you talk about embodied energy, we're seeing a lot of homes go to triple glazed windows for the sake of just going to triple glazed windows, as opposed to looking at a window's overall performance, which when you talk about the natural gas we're burning to produce the triple glazed product, if 1.5 is sufficient, we actually get a win-win by reducing embodied energy and we get high performance. So what's the math that's working there that makes this work?
So in this particular case here, what we're looking at is we're looking at very simple building geometry, right? Which is the key here. And we're looking at, so because we're a passive builder, we're a passive house builder, and we know we do glaze tuning as well. So you're right, you're absolutely right. Not all energy advisors are well versed in this. We're just fortunate that we have a ton of experience in it, right? So what we did here is we came to the table with fundamental principles of understanding that building geometry is the #1 component. Because of that, because the energy loads on this house were so small that we could kind of like, I want to say this is going to sound a little weird, but I'm going to say it this way. We could burn energy through a lower value window because our building geometry and our insulation was enough that it was adequate to make up for it. We look at houses as a system now, right? So when we're looking at the house as a system, you can do whatever you want. Incidentally, I mean, building code won't allow you to do this because I think BC changed to U1.6 windows. But theoretically, you could put a single glazed stained glass window all facing north in your house, assuming the rest of the house was adequate to make up for that window. So, but you're all right. If we don't typically build houses like this, right? We came at it from fundamental principles. Most people are going to kind of, you can see this house next door, right? Where's my pointer? There we go. We got a few bump outs in here. Those bump outs themselves might bump those window requirements up. We were also seeing, as far as triple glazed windows are concerned, in high traffic areas, we're seeing people put triple glazed windows in for sound dampening is another reason why we're seeing it. So it's more of like an occupant comfort factor. But then you're absolutely right. We need to start looking at cooling and proper cooling, particularly if those windows aren't glazed tuned properly. I don't know what the solution is there, because the energy advisor training is like kind of tough sometimes for EAs to kind of understand all of these principles. And yeah, I'm with you on that. So this house has 1.5 windows in it. So, and it has to do with the geometry of this house. So, and I will put this out there. The modeling software that we use for ERS compliance right now does not calculate cooling loads very well. And it's known, it's something that's being worked on right now, and they understand that this is something that needs to change. So this is something that is happening. When it happens is another story. Hopefully that answers your question.
I would emphasize, like, a lot of what we do in our business is window replacement in existing homes. And it is the ¡1 reason for people to replace windows in their home today is overheating, not cooling.
Yeah.
So, and just to put it in other context is what the city of Vancouver is doing, now mandating a 1.22 U-value windows for single family homes, is kind of maybe counterintuitive to what you're talking about here in regards to the trade-offs and the efficiencies. And the what I've been sort of saying to everybody is this need for prescriptive requirements in the building code is actually preventing the integrated design process from being successful.
Right. So what we are seeing though is under step code in remote areas, and those areas are going to be defined, is that there is going to be a prescriptive pathway. Because getting an energy advisor to Haida Gwaii where they build 3 code compliance houses a year, they're like, maybe that's not feasible, right? It's not worth it for somebody to set up a business there. So that is where I see the U1.2 values coming in as well. I didn't know that the city of Vancouver requires that, but I agree with you. The performance pathway is totally the way to go. Unfortunately, I'm not at the helm making those decisions. All I can do is advocate for it and things like this. I'm with you. I'm totally with you on that.
Yeah, I'd like to add a couple of words with that. I think this is where, the importance of integrated design and having an energy modeler very early on on a project is like very, very valuable, because what's happening here is that one building is like it's moving, you change one thing, something else might also change, so it's always moving. So you need someone to take that decision early on and to design it accordingly. So that's why we kind of emphasize on integrated design, and also we advocate for having an energy modeler way early on the stage. And yeah, I agree with you. It's integrated design is the way to go forward.
Yeah. Cool. I'll just jump into the next question. Laura, I see you've got, so you're talking about the red list material. It was difficult. It's very difficult. I mean, it's kind of beyond the scope of this, but it was a difficult project. It was a lot of work. Very happy we did it. I don't see the Living Building Challenge becoming a standard that everybody's going to be able to do, but it's about changing industry standards. So I'll just leave it at that. You can email me if you'd like more information on full pedal LBC stuff, and we can maybe have a side conversation about that. Julio, presentation online. Maybe I'll put that out to the team here. Are you guys going to make these slides available?
Yeah.
Great. They say yeah.
Yeah, we put it on our webpage, tol.ca/gblearn.
Yeah. Great. So Andrew, any thoughts on why the most common number I see on step 3 houses is 2.5? Is it because it was higher and they were running around caulking things? If you're talking about the compliance form, it's because that's what compliance is. Compliance is 2.5 ACH. So we set the target. We want to give, when we do our initial modeling, we set the target to 2.5 because that is the lowest performance that you can have as far as an air exchange target is concerned. So, and you can absolutely do better. but we want to give you a little bit of breathing room. So if you hit 2.49999, our modeling takes that into account. We're good to go. You're compliant, no problem. Paperwork done. City's happy. Everybody's happy. You're happy. Good to go. So hopefully that answers your question. Yeah, mid-construction testing, are we running around and caulking things? Sometimes, if we see a fail, but that's why we show up and do it at that point, right? So we can fix it before the drywall goes on, because the cost of fixing it at that point is significantly cheaper than fixing it when your finishes are in the house. I would argue that you're going to have bigger problems at that point. So, yada, yada, yada. Okay, great. Yeah. Opinion on exterior shutters. Yeah, Wally, yeah, I agree. This is where we're talking here. EnerGuide does not recognize their value. And the reason for that is that we have to be careful under EnerGuide when we're talking about when people can open and close blinds, because you might close the blinds, but somebody else might not close the blinds. So when we're reliant on the occupant to make things happen in the build, we get a little bit, at least EnerGuide, not we, I guess, EnerGuide, their take is that if they require you to close the blinds and say you're not home and you don't do it, I don't know, can they take that into account? I would absolutely say that there's value in it, for sure. The modeling doesn't take it into consideration, but that doesn't mean that, once again, the predictive and how you operate your house depends on how you drive the car, right? So if the homeowner is going to drive the car really well, close the blinds when they need to, open the blinds when they don't need to, great. They're totally going to have a way better time in that house. But if somebody else doesn't and they drive it really fast and they're revving the engine the whole time and leaving the blinds open, I don't know. So are they a good idea? Great. Why don't they take them into consideration in EnerGuide? I think that's why. I don't speak for EnerGuide, but I think that that's why. IGUs only or the whole frame when it comes to overheating. Oh, that's to Anton. Maybe Anton can answer that. Yeah, great.
Yeah, I can if you want me to jump in on it, just to answer that quickly.
Yeah, that'd be great.
It depends on the low E that was used in the frame that's in the window. Energy Star, for example, rewards a window through the ER path with high heat gain, so it can overcome a poor performing frame. So in some cases, we'll replace the frame and the window if that window was used from an Energy Star perspective. What we like to do is consider the envelope burst approach and reject the heat coming in, so you reduce your cooling load. But that's counterintuitive for winter heat gain that you're looking for free heat. So there's this real passive balance effect that we have to always take into effect, and they're really counter opposing each other. That's just what we're dealing with. So
yeah, great, thanks. Yeah, the as-built report, that's going to be up to your energy advisor. We're required to put your actual target on there. So whatever you actually get, that we model it out as that, and on your as-built report, that's how we put it on. So the as-built report, if they don't change it on the as-built report, it's probably pulling it from your pre-permit report that's automated in the step code compliance form. So it'll be up to your energy advisor to change that. Great. All is future owner, if they have open windows and doors, leave them open. This is all for nothing. Yeah, we absolutely need smart, informed owners, but I mean, it's your energy bill, I guess, right? So yeah, great. Let's keep scrolling through here. Great. I don't see any other questions. Anybody's hands up? No? Great. Maybe I'll pass it back to Kevin here for the last 5 minutes.
Thanks, Dallas. That was really, really great. Yeah, I think we can wrap things up. So again, thank you so much, Dallas from Bernhardt Consulting. I think we learned a lot during that presentation, and it's really great to see those real life examples and hearing from your real life experience, speaking kind of boots on the ground. So that's really, really great. I want to give a big thank you to all the attendees here today. I think this is by far one of the most engaged workshops we've had. I think Sarah and Najim would agree that it's probably a lot of activity in the chat going on. So I really appreciate that. That's what these forums are for. It's actually it's a forum. It's the Builder Forum, and it was really set up to have people chatting and asking questions. Since we went online, I think we kind of lost a little bit about that. However, it looks like it's back. So that's really great. I really appreciate that. Today we talked about a critical bylaw proposal around our energy step code consultation. We offered at the beginning of the lecture a number of different ways to provide feedback. So the chat is basically going to close once we're done with the workshop today. However, as noted, greenbuildings@tol.ca, you probably already have that email in your inbox. And you will also get a survey post event to provide that feedback. And again, both of those avenues are time limited. So if you wish to provide feedback, please do. As well, and this is really, really great. It looks like there's been not only just dialogue between the attendees and our consultant Dallas and ourselves here, but there's been some dialogue between actual attendees and themselves, and that's really great. And this is again the point of the forum. So we're really, really happy that our attendees are engaging with each other. So please use this time or for our next time to talk to each other. And that's really, really great. I'm really, really thrilled with the outcomes of today. So thanks again. Again, please provide feedback if you have any. And I won't share my screen, but there are credits available for your respective association. And if you do need to send in documentation, you can. You'll get a receipt of the time spent in the lecture. Again, I think we'll leave there. Thanks so much. We look forward to seeing you in the fall. Bye, everybody.